morning, grade 4s. Today we are going to continue talking about geometry, which is basically the study of different shapes and lines and things like that. Yesterday we talked about a few words, and I just want to review those before we get into anything else. So I'm going to create a little bubble here. So some of the new ones we had was something like a line segment, which was basically part of a line, and we can know that it's cut off because it finishes with 2 points like this. Another word we talked about was parallel lines, and parallel lines meant that there were two lines, but they were never, ever, ever, ever going to touch. They never will intersect. They go on straight for the rest of their lives. It's sort of like train tracks. And we also talked about when two lines meet like this at what we call a 90-degree angle. That's called a perpendicular line. That means they go straight up and down. That may be important today, that may not be. So today we are going to move on from lines, and we're going to talk about different types of shapes. So we're going to start with our first one, which is a simple closed curve. This basically means any shape we want as long as it is fully closed. So this could be something like a square, it could be a circle, it could be a blobby shape like this. It could even be like just random lines, straight, curvy. It doesn't really matter as long as it is closed. Now, if it wasn't closed, it would look something like this. That would not be a simple closed shape because, as you can see, it is not fully closed. If I went to color this in, I wouldn't know what to do with that because it isn't fully closed. It's sort of like the paint tool on a computer. If I tried to put a paint tool on here, it would cover my whole screen because that little thing wasn't closed. So that is an example of not a closed curve, but any one of these shapes is technically a closed curve. So that's the biggest generalization. If you have a shape, it is automatically going to be a closed curve. Now we're going to get a little bit more specific. A polygon is a type of closed curve that only uses line segments, or other words, straight lines. So for example, a square would still be considered a polygon because it's made out of straight lines. This shape here couldn't be a polygon because it's not made out of straight lines. But we could have a triangle. We could even have some more weird shapes, like a weird L shape. That technically is a polygon because all the sides are straight, even though my drawing is not very good. However, something like this, a circle, would not be considered a polygon because its lines are curved. So we don't count it in that section. Now we're going to get even more specific. A triangle is a type of polygon, is a type of simple closed curve, but it is made out of exactly 3 line segments, or 3 straight lines. So here's an example of a triangle. Another triangle could look like this. Triangles can look like this. As long as it just has 3 straight lines, it is good. It is a triangle. A triangle could even look like this. Really weird. However, as soon as you have more than 2 lines, no longer a triangle. So some polygons are triangles, but not all of them. So this, for example, isn't a triangle. That's not a triangle. It has to have 3 sides to be a triangle. And the way I remember that is the word tri. That little tri right there means 3. Like a tricycle has 3 tires, a triangle has 3 sides. So if tri means 3, what do you guys think quad means? If you have a quad, how many wheels does it have? The answer is 4. A quadrilateral has 4 sides. And so remember, all of these quadrilaterals down here are technically polygons. They're technically simple closed curves. They're just a bit more specific because in order to be a quadrilateral, you have to have 4 sides. And within all these quadrilaterals, we have special names for some of these. And I'm going to go through the names with you right now. Some you might recognize, some you might not recognize. The first one I'm going to talk about is this buddy over here. This is called a parallelogram. A parallelogram means that it has two sets of parallel lines. So if I look here at these two lines, if I drew those lines to be even longer and I put them next to each other, those lines would be like train tracks. They'd never ever meet because they are the exact same distance apart all the time. And it's the same with these two lines over here. Oh, there we go. It's the same with these two lines. If I continued this line and continued this line, they would go on forever and ever, just like train tracks. So the only requirement to be a parallelogram is two sets of parallel, I'm going to draw it like this, lines. Now you'll notice a lot of these have that. So for example, if I compare these lines, those are also parallel lines. So technically, this is a parallelogram. Technically, this one's a parallelogram too. And even my square here is technically a parallelogram because its lines are parallel to each other. These two lines are parallel and these two lines are parallel. So technically all of those are parallelograms, but we have better and more specific names for them. For example, this one here looks sort of like the parallelogram, except if I took my ruler and I measured this side and this side and this side and this side, I would find that all four of those sides are the same length. So if this one was 2 centimeters, this one would be 2 centimeters, this one would be the same, and this one would be the same. It's basically like a square, except it's a square that's sort of been slanted and tilted on its side. The name we call this one is a rhombus. You might have also heard it referred to as a diamond. But we like rhombus because that's the more mathematical term for it. So if your shape has two sets of parallel lines and all the sides are equal, it is a rhombus. Is there any other shape that technically meets that curriculum? Well, yeah, a square technically does it because all the sides are the same and there's two sets of parallel lines. So technically, this is a type of rhombus too. But we don't really go around calling it a rhombus either, do we? So now we're getting into the really specific ones, the rectangle and a square. These are probably the most common shapes, but you need to understand why it is a rectangle and not just a regular parallelogram. So the key thing for a rectangle is, yes, it needs two pairs of parallel lines, but they all need to meet at that right angle, so they're perpendicular to each other. If they meet at a right angle, then it's a rectangle. And a square gets even more particular. In order for a square to be a square, its sides need to be parallel, its sides have to be the same length, and all the corners have to be at 90 degrees again. So in order to have a square, all three of those things have to happen. Now you may notice I've left our last little quadrilateral over here unnamed so far. That's because unlike all of these that have parallel sides, this one only has one pair of parallel lines. If I extended these two lines, they'd be parallel, but if I extended these two, that train track is not going to work. They're going to run into each other. So both sets of lines aren't parallel. We have only one set of parallel lines. And when that's the case, we don't call it a parallelogram. We call it a trapezoid. So this one here is a trapezoid. It's still a quadrilateral, but this time it only has one set of parallel lines. A little bit tricky for you. So as you notice with our quadrilaterals, a lot of these don't just have one name. So what we're going to do is we are going to find all the possible names we could find for a square, and then we're going to discuss why that name works for a square. So let's try that out together in the bottom right here. So first of all, I'm going to start with my first thing. I know for a fact that a square is a simple closed curve. And I know that because there's no opening in it. It's closed. So that's one thing we could call a square. It's not the most accurate name, but it's one thing. We could also call a square a polygon because all of its sides are straight lines. And if they're straight lines, it can also be a polygon. Can we call a square a triangle? No, we can't because there's 4 sides, not 3 sides. So we can't call it a triangle, but we can call it a quadrilateral because it has 4 sides. So there we go. We already have 3 different names for our square. What else can we call a square? Well, we know that within the quadrilaterals, it has quite a few different names. First of all, we know that it has 2 pairs of parallel lines. That means it is known as a parallelogram. We also know that all the sides are the same length, and if all the sides are the same length, it can be known as a rhombus. We also know that its corners meet at 90-degree angles, and if they meet at 90-degree angles, it could also be called a rectangle. But because it has all 3 of those things, we can finally call it a square. So look at that. Look how many names a square can take on for itself. Let's try another one and see if we can get that one as well. I'm going to draw a shape here. Ooh, okay. So here's our shape. Let's see how many names we can come up with for this. So first of all, we know it is a closed curve because there's no openings, it's all connected. We also know that it is a polygon. Why? Because all the sides are straight. It has 1, 2, 3, 4 sides, so it's not a triangle, it must be a quadrilateral. And what type of quadrilateral is it? Well, it has parallel lines this way and parallel lines this way. So 2 sets of parallel lines makes it a parallelogram. Are all the sides the same length? Oh, that's not the same as that, so it can't be a rhombus. Does it meet at a 90-degree angle? Does that look like a little chair? Nope, so it can't be a rectangle. Can't be a square, can't be a trapezoid. So I guess that might be all the names we can possibly give our parallelogram. So overall, this one is a parallelogram. One of the questions will have you doing this, going through the different things. I guarantee you every single one of your shapes will probably be a closed curve and a polygon. So if you want to put those 2 in first, then you can fill out the ones that you are missing below. I wish you the best on your math today, everyone. Goodbye.